All right, we are graphing absolute value inequalities. So this is section 2-8, graphing absolute value inequalities, day 3. Our objective is going to be to graph an absolute value and then to apply the rules of inequalities. That means everything we talked about last week is still going to apply. So we are still going to apply the rules for dashed versus dotted and solid. We're still going to shade above or below. Now the shading is just kind of more like an in or out. So let's see exactly what that means today. So looking over here at the very first example, we have y greater than or equal to the absolute value of 2x minus 3. So the a value is our 2, and the x minus 3 tells me that we are shifting or translating this graph down 3 units. So our vertex is going to be 0, -3. So we're going to plot our vertex. Then, because the graph is greater than or equal to, we are going to have a solid line based off those points. So again, here are all the points on my graph applying the vertex and our slope. So if we just connect all of those points, it will be solid. We have arrows showing it continues upward. And then we need to determine, are we going to shade inside the absolute value or outside the absolute value? Now we can determine this shading based on the fact that the absolute value has a test point within it. So our test point is going to come from either the inside or the outside. Let's say I select a test point of 0, 0. A 0, 0 test point is inside the absolute value. Since that test point turns out to be true, we are going to shade inside the absolute value. So again, we pick a test point. In this case, we picked one inside our absolute value. Since our test point was true, we shade within. For the next example, our graph is shifted down 3 and left 2, making my vertex -2, -3. So we're going to go over to our graph and plot our vertex point, -2, -3. The slope is up 1, right 1, or up 1, left 1. And then this time, because my graph is greater than, but not equal to, my line connecting each of those dots has to be dashed. My favorite test point is always 0, 0 because it is the easiest numbers to plug in. So once again, we are going to test point 0, 0. Since 0, 0 is inside the absolute value, if it turns out to be true, we would shade inside our absolute value. If it turns out to be false, then we shade outside. So in this case, 0 is greater than -1. Therefore, it is true. Therefore, we shade inside the absolute value. All right, sometimes our absolute values aren't solved for. So we know from previously graphing absolute values that in order to graph them successfully, we need to solve for y equals. So the first thing we're going to do in this example is to isolate our y value. So in order to do that, we are going to move over the 3 and divide by 2. So let's go ahead and do that now. Okay, that leaves me with y less than or equal to negative 1/2 x minus 5 minus 3 halves. So the slope is negative 1/2. That tells me my graph is reflected and my slope is down 1, right 1. It also tells me that my graph is going to be compressed. My vertex is 5, negative 3 halves. So it tells me the graph shifts down 3/2 units and it shifts to the right 5 units. So we're going to plot our vertex. And then we're going to apply our slope. Thus giving me my graph of the absolute value open down. And again, this is a less than or equal to, so my line is solid. At this time, I'm going to pick my test point. So I pick a test point of 0, 0 once again. Now, the only time you can't pick a test point of 0, 0 is if your absolute value goes through 0, 0. So in this case, plugging in that 0, 0 test point gives me that 3 is less than or equal to a positive 5. And in this case, 3 is less than or equal to a negative 5. So that is false. So since our test point is false, we do not shade where our test point is, which means once again, we are shading inside our absolute value. And again, that should make sense. The y values are less than. Where is y less than? Well, y is less than right here below the absolute value. Always less than where it's shaded. Okay, same thing in the next example. We are going to solve for our y value. So we're going to subtract 2. And then we are going to divide by a negative. Now you need to recall that with inequalities, if you divide by a negative, it changes the direction of the inequality. We then see that our vertex is at negative 3, 2. The graph is reflected. Its slope is negative 1 over 1. And now, because of the division of negative 1, the y value is greater than. So since my y value is greater than, I need to shade the y values above the graph. So again, it's reflected. It is shifted down. Not down, up 2 and left 3. So here is my vertex. And then plotting my negative 1 slope, I have the following. It's dashed because the inequality is greater than but not equal to. Test pointing is 0, 0. We get that 0 is greater than negative 0. Absolute value plus 3, Close that absolute value, add 2, CO3 becomes negative. Negative 3 plus 2 is negative 1. 0 is in fact greater than negative 1. Therefore, we shade where my test point is because that test point is a true value. All right, guys, go ahead and try the rest of these on your own. Your homework is that next page in our packet.